All right, domain and range. This was something we did last semester. What does domain stand for in any function? X values. Can you tell me all of the X values on this little partial parabola here? Why can't you tell me all the X values? Because there's billions of them. Any point that's on the graph is a solution. So there's these nice two whole numbers at the endpoints, plus there's billions and billions anywhere along the curve. Okay, so what's the best we can do then if I ask you to tell me the domain? Right, you can tell me the lowest one and the highest one, and then all of the other X values have to be somewhere in between. So on a picture, you want to look at the left and right edge. My left edge is at -3, -1, and my right edge is at +3, -1. Now, I'm talking about domain, so what number do I not care about? The -1. My lowest X value is a -3. My highest X value is this +3, and all the other X values are somewhere in between. So we would write that as -3 is less than or equal to X is less than or equal to 3. What if one or both of the endpoints had been an open circle? Like what if there was an open circle here at the 3? Right. Then you wouldn't put the line underneath the last endpoint. Are y'all okay with that? We still haven't had a grade on this yet, and we will. All right, now range. Range is the top and bottom. Range is about what letters? The Y values. And again, there's billions of them here. Let me show you the answer that a lot of you fell for on the CBA. Okay, the wrong answers are called distractors, and they're trying to distract you away from the right answer. What's the lowest Y value you see? -1. The bottom of the graph occurs in two places, right here and right here. -3, -1, and 3, -1. But now I'm talking about range, so I don't care about the 3's or the -3's. I care about the Y values. What's the highest Y value? 5, up here. Let me show you what one of the choices looked like on your CBA. Some of you really liked that answer, and you picked it. What's wrong with that answer? Yeah, 5 is part of the answer. If I didn't want the 5 included, even though they didn't put a nice big huge dot at the 5, it's definitely part of the answer. And if I wanted to show you that it was not included, they would have to put an open circle there. If there was an open circle at the 5, then absolutely that's your answer. But there wasn't. So they put two answer choices down there that looked very similar. And unfortunately, some of you fell for the wrong one. This is actually the correct answer. The -1 was colored in, and the 5 at the top was colored in. Okay, so please don't fall for those tricks. All right, now, number 2. How did you guys do this one? With the table, yes. This is the one I wanted you to do in the calculator. This is one that if you see it on the end of course exam, you should say, thank you. That's a gift. If you're given a function rule, you want to go to y equals and enter that function rule. Y equals -2/3 x squared plus 6x. Now, what does f of 12 mean? What are they asking you to do? Well, they want you to put a 12 into the function. But rather than do that by yourself, and let me caution you guys, some kids did this without entering it into y equals. They just decided to let the calculator do the computing for them. Did you guys do this? -2/3 times, oops, that's -23. Some kids tried to actually get the calculator to do the math for them. -2/3 times -2/3 squared. You see what I'm saying? I would not recommend that because it's easy to input something incorrectly. The safest thing to do with those is to go to y equals. If they give you a function rule, you want to go to y equals and enter it. -2/3 x squared plus 6x. Now they're asking me to find f of 12. So what do I do next? Yeah, go to the table set and tell it to start at 12. They are giving me an x value and asking me to find the y that goes with it. So what's the answer? -24. That's the safest way to do those, and it should be a complete gift to you. So if you see those on a CBA or an end of course exam, say thank you, and then don't miss it. There's no excuse to miss those. All right, get out your homework. I'm not sure if I emphasized it in this class or not, but I want to look at, I'm going to give you a chance to fix your answer on one of these real quick, because I don't know if I don't remember if I emphasized this or not. I'm trying to think of which one it was. I think it's number 8. Okay, let's look at number 8 before we grade these for real. Number 8. The question was y equals 2x squared minus x minus 10. Now, on this one, it's kind of like the number 2 that we just did on the warm-up. We're going to figure out what x value we want, and we're going to get the calculator to tell us the y that goes with it. So it's you got to do a little bit of work. You have to find the right x value. What is the x value of the vertex? How do you find it? What's my little formula? Opposite of b over 2a. Okay, so that part's not hard to do. A is a 2 in this problem, b is a negative 1, so what's the opposite of b? Positive 1 over 2 times 2. So my x value that I'm supposed to use for number 8 was 1/4. Okay, so let's everybody try this with me, because I want to make sure you know what you've got to do here. The t-chart has limited space. So I'm going to put in y equals 2x squared minus x minus 10. I know that the x value I'm supposed to look for is 1/4. So I'm going to go to table set and tell it to start at 1/4. Then I'm going to look at my table of values. Please, please, don't just assume that negative 10.13 is the number to use. What do I need to do? Well, no, not just that. I need to hover over it. And then look at the bottom. It's not really negative 10.13. It's just that's the only space the t-chart had. What's the real value of y? Negative 10.125. It's just the t-chart ran out of space. So it rounded up that 0.125 to 0.13. Now, which one's more accurate? Negative 10.125. I mean, you'd get a fraction that's very close to the right answer, because these two numbers are very close. But you're going to get a different fraction depending on which value you use. Always hover over the y value and look at the bottom to get the most accurate picture. Did I say that yesterday? So if you didn't do that, then instead of using negative 10.13, real quickly right now I want you to do negative 10.125 and change it to a fraction. It will give you a different fraction than negative 10.13 would have. Did I emphasize that you were supposed to reduce? Yeah, okay, good. You can change it real quick. You take negative 10.125 right now and change it to a fraction and change your answer, and then I'll uncover it if you haven't already seen it. Okay, so here are your answers. They're going to be 10 points each, but I will also give partial credit. So for example, if you got the x right but the y wrong, instead of taking off 10, you can just take off 5. Now here's an example of homework that you don't necessarily have to have work shown, because most of this was calculated. The only work you really had to do was the opposite of b over 2a. And then the calculator found the y for you. If you got one part right and the other wrong, well, now I said you could change it. So if you changed it correctly, then you don't have to count it wrong. But from here on out, folks, if you're looking at your t-chart, hover over the value and look at the bottom to get the most accurate value. All right, any questions on these? Yes. Number 2. What did you get for your y value? I'm just curious. Oh, but you don't have the same x value? You probably just didn't reduce it. Okay, I told you that I don't mind fractions that are improper. I don't mind when the top is bigger than the bottom. I do mind if it's not reduced. So on number 2, the question was y equals negative 4x squared plus 20x minus 25. So the opposite of b would be negative 20 over 2 times negative 4. negative 20 over negative 8. Now, you don't have to reduce it to get the right y value in your calculator. But for Mrs. Hine, when I want you to give me the x value, I don't want to see negative 20 over negative 8. You got to clean it up. First of all, a negative over a negative is really a positive. And 20 and 8 is reducible. What can they be divided by? 4. Some kids divided by 2, and they got 10 over 4, but that's still reducible. If you divide by 2 again, you're going to get 5 over 2. Or you could have chose to divide by 4 in the beginning, and you would end at 5 over 2. So if you got the y value wrong, correct, but the x value wrong, you can just take off 5 points. Just reduce, because I'm telling you, on multiple choice items, they're not going to have negative 20 over negative 8 as the choice. They're going to have positive 5 over 2. So I want you to get into good habits. Yes? Number 4 and 5. Let's look at number 4. Y equals negative x squared plus 9x minus 18. Right? What's the opposite of b? Negative 9 over 2 times negative 1. So negative 9 over negative 2. A negative over a negative is really positive. So I would like you to report the x value as positive 9 halves. All right, do it in your calculator right now, and let's just see what happened. Some kids just enter things incorrectly. This is number, which one am I doing? 4. Y equals negative x squared plus 9x. And please make sure you use a minus sign in front of the 18, not a negative sign. Okay, and then I'm going to tell my table to start at 9 over 2. Oops. That's not the right place, is it? Table set. I'm going to tell my table to start at 9 over 2. They're 10 points each. Okay, and then my y value showing is 2.25. But I wanted you to give me all fraction answers, so then I'm going to go back to my regular screen and punch in 2.25. Math. It's already on fraction. Enter, enter. 9/4. Yes, that's one way to do it. There's more than one way. What were you doing? Yeah, because you got to control, like, usually your table is usually set to do nice whole numbers. Okay, but if you are looking at nice whole numbers, I'm not going to see 9 over 2 as an x value, which is 4.5. So I've got to control my table. I'm going to tell my table what x value I want it to use. So I'm going to tell my table, hey, I want the x's to start at 9 over 2. Otherwise, it's not going to show up. Because normally your t-chart is set up to just show nice whole numbers. Trey? Yeah, the t-chart's going to show you decimals, but I asked you to convert them to fractions. Because they will not give you like a fraction x value and then a decimal y value. So I need you guys to be really good at going from one form to the other. Yes, question? On the fraction, it doesn't matter. Like, for example, number 6 is negative 5 over 2 for the x value. You could have 5 over negative 2. It's just, that's not how it's normally shown. If a fraction's negative, they're usually going to put it at the top or out to the front of the whole thing. But yeah, that's the same thing. I'll accept that. Yes. For the y value? Okay, we'll try it again real quick. You keep getting the same y value. And you're using negative 5 over 2 for the x? Okay, look at your y equals. Let me make sure you're, this is number 6, right? And you keep getting the same wrong answer. Let me try something, because here's a common mistake kids make. Negative x squared. Some kids accidentally use a negative sign in between that and the 5x and the plus 8. Let me see if that's what you did. And table set, what is this one's number 6, negative 5 over 2? You're getting 7 over 4? Okay, I'm trying to figure out what mistake you're doing. I entered this incorrectly to see if that's what you did, but it doesn't look like this is what you did. Make sure that in between your terms you've got a subtraction sign. So, negative x squared minus 5x plus 8. I'm going to tell my table to start at negative 5 over 2. And I see 14.25. Is that what you had? Okay, well, do it right now with me. Let me see. Is it still showing that? And then I want to quit and do 14.25 as a fraction. I'm still getting 57 over 4. I'm just trying to figure out what it is you're doing wrong. Why don't you bring it up here and let me see how you entered it. Okay. Always don't forget, it's always a good idea to clear your calculators before you start, because who knows what weird things the class before you did. All right, pass those up. 10 points apiece, or 5 for one right, one wrong. Okay. Oh, you put a -8. It's a +8. See, that's a minus sign. It should be a plus sign. Okay, pass those up. Get out your notes. You guys are about to have a nice long weekend, so the homework I'm going to give you, I'm going to give you 15 or 20 minutes to do it in class, and most kids were able to finish. So let's get through our notes. 10 problems. And it's in the calculator for those of you who hate to show me work. It's calculator problems. I will give you back your homework in a minute. All right, today we are going back to something we learned before the break, but we kind of rushed through it, and I want to make sure you have your calculator skills up to par. Plus, some of these you're going to have to do with a calculator. Okay, there are some questions on the end-of-course exam and your CBAs where you can't rely on your brain no matter how smart you are. So, what we're going to go back to doing today is focusing on finding roots of quadratic functions. Ramiro, you really want me to say your name again, don't you? Everybody noticed I called you out yesterday. They were laughing at you in 4th period, just FYI. Sit up. Get out your notes. Let's be focused. There you go. Good job, Ramiro. Okay, roots of a quadratic function. Real quickly, let's just review what a quadratic function is. What's another name for a quadratic function? It's got an x squared in it, absolutely. Sometimes the picture it makes, we call it a parabola. So if you've got an equation in the form of y equals and it's got an x squared in it, it's going to be a quadratic function, a parabola. We have done several things with parabolas. We have been focusing lately on finding the vertex. And we can do that with our brain. We can do that with our brain and our calculator. There is a way to do it completely in the calculator. We'll talk about that next week. What's another name for vertex? The what? The minimum or the maximum. This one would be a what? The one I just drew. That's a minimum because I've got a happy parabola. I've got a positive a value. There's one other word for it. Turning point. It's not necessarily the y-intercept. I mean, sometimes it might be, but this isn't where it's crossing the y. Okay, so vertex, minimum, maximum, turning point. And the way we learned how to do that, you can do it just with your brain. You can do it with a combination of brain calculator. And there is a way to do it completely in the calculator. We'll talk about that next week. And the biggest part is the opposite of b over 2a, and then you find the y that goes with it, right? Now, before the break, we spent weeks upon weeks upon weeks doing factoring. Factoring isn't dealing with finding vertex. What did factoring help us do? Find the zeros. The other thing that we have been working on is finding the zeros, otherwise known as the roots, otherwise known as the x-intercepts. Okay, and there were several ways we did that. What's the first way we ever learned about how to find roots? By factoring. We would set it equal to 0, and we would factor it and solve it. Factoring and solving. That's the way we spent weeks doing. Then we learned a little formula that you guys really liked. What was that called? The quadratic formula. Opposite of b, plus or minus, square root of b squared minus 4ac, all divided by 2a. And then, I don't know if you remember, but we did learn a way to do it in the calculator. We did. And we're going to go back and do that again today. So hopefully it'll come back to you. Okay, now, when we're talking about zeros, true or false, every parabola has zeros. Thumbs up for true. Every parabola has zeros. Thumbs down for false. It is false. Not every parabola has zeros or roots. Not every parabola will cross the x-axis, and I'll show you some pictures in a minute. True or false, every parabola has a vertex. That's true. Every parabola has a minimum or a maximum, but not every parabola will cross the x-axis. True or false, a parabola could have two roots. True. True or false, a parabola could have one root. That's true. True or false, a parabola could have three roots. Okay, draw a parabola that's got three roots. A parabola. Now remember what a parabola is. A parabola is a smile or a frown. No, it can't be a squiggly frown. A parabola has to have this basic shape, so it cannot have 3 or 4 or 5 roots. It's either going to have one root, two roots, or no roots. Now let's talk about what those situations would look like. Most of the ones that we did crossed the x-axis twice, so they mostly had two roots. But every once in a while, and today this is going to happen to you as well, you might come across a parabola that never touches the x-axis at all. So this kind of picture would have two roots. This picture has no roots. And then occasionally you'll get a special situation where your parabola would only cross the x-axis one time. Now look at this case. What's special about these guys? The vertex. Sometimes you only have one root, and that's going to happen when the vertex and the root are the same point. When the vertex and the root are the same point. In other words, the turning point, the vertex, is on the x-axis. And that does happen sometimes as well. Now, again, we did this by factoring, but not every quadratic equation can be factored. So then we talked about, oh, well, then we could turn to the quadratic formula. And remember how we would sometimes get numbers inside the radical sign that were not nice whole numbers? Like you might get an answer like this, 4 plus or minus the square root of 20 over 2. And I would just let you leave it like that. Y'all remember that? Well now, no, we're not going to use quadratic formula. But if we were to work this out, it would give us some weird decimal that goes on forever. If we were actually to get the calculator to do that for us. Well, that's what's happening on today's roots. They're not nice whole numbers. They're not factorable. You could do it with the quadratic formula, but we're going to get the calculator to do it for us. Okay, here we go. Number 1, y equals 2x squared minus 8x minus 6. Now, this is different than what we did yesterday. Yesterday we found vertex. Vertex and roots are usually not the same thing. Every once in a while you'll get a special case where it is. But on vertex, you figured out the x and found the y that went with it, right? So we have a way of finding the x value for vertex. That's not the case for roots. When we're finding roots, we don't know what the x value is. We know what the y value is. What do we want the y value to be if we're finding roots? 0. When we are finding roots, we can't control the x. We don't know what the x is. We know what the y is. That's a little bit trickier. It's real easy when you know what the x is. You just look at the t-chart, and you tell the t-chart to start wherever you want it to. But the problem here is we don't know the x value. We know the y value, and that's a little bit trickier. So this is what we're going to do. We're going to enter both equations into y equals, and we're going to see where these things do what? Where they intersect. We're going to see where this intersects with the x-axis. Guess what y equal 0 is? It's the x-axis. The equation of the x-axis is y equals 0. So we're going to enter the equation for the x-axis, and we're going to enter our function rule, and we're going to see where those two things intersect, if they intersect. So put that into your calculator and look at a picture of it. The first thing I would do on any problem from here on out that you're asked to find the roots for is I would put the function rule into the calculator and look at it and make sure it has roots. Because again, we talked about you don't always have roots on a quadratic function. Okay, y equals 2x squared minus 8x, oops, minus 8x minus 6. The first thing I would do, enter it. Make sure you enter correctly. Make sure you use subtraction symbols in between your terms. Let's just glance at the picture of it real quick. Hit graph and look at the picture. Does it look like it has roots? Yes, it looks like it has 2 of them. Now, they're not nice whole numbers, though. Look at this one. The one on the right looks like it's crossing at about 1, 2, 3, 4, somewhere in between 4 and 5. Are you with me? So one of my roots, I'm just going to make a mental note, should probably be somewhere between 4 and 5. Look at the other root. It's between what? 0 and -1. Okay, so my other root's probably somewhere between 0 and -1. And I'm just going to tell you, if I asked you to factor this, you couldn't factor it. It's not factorable. The roots are not nice whole numbers or even not nice fractions or decimals. So we're going to get the calculator to do it for us. Now, if I don't know the x, and I don't, I'm trying to find the x, and I know the y, this is how you could do it for almost any function where you're trying to find a certain y value. I can't rely on the table of values anymore because I can't control the y values. And just look, let's scroll up and down the y values. Do you see where a y value of 0 anywhere? No. And the reason why is because the x value that gives us a y value of 0 is a weird number. So I can't control the x's when I'm looking for a y value. What I can do, though, is go to y equals and enter another function. What do I want y to equal? 0. Which is the x-axis. I want y to equal 0, which is the x-axis. Now, some of you have those nice yellow calculators. Some of you don't. If you don't have a yellow calculator, I want you to look on somebody who does. Because when you enter 2 functions on a yellow calculator, the flat yellow ones, it does something real nice. It shows one of the functions in one color and the other function in a different color. That's nice. I don't want you to get used to that, guys, though, because you probably won't have one of those newer calculators on test day. Yeah, because the line, if you're looking at a yellow calculator, it's going to come through and color in a different color across that x-axis. Because what we are doing is we're trying to figure out, here it's going to draw this curve, and then it's going to draw the y-axis again. And we're looking to see this point and this point, where they do what? Where they intersect. Okay, so this is completely different. We're not controlling the x's. We don't know the x's. We can control the y by putting in what we want y to equal. Now, I put in my 2 functions. That's important. If you don't put in both functions, it's not going to work. We know what we want y to equal. We want it to equal 0. Then I'm going to go to calculate. The calculate key and the trace key are the same key. They're right here at the top. You see where I am? So I have to go to second function, trace. And then it gives me a list of things I can calculate. We are calculating where these 2 things intersect. So you can scroll down to 5, or you can actually just type in a 5. Now, it's going to ask you 3 questions, so follow with me here. The first thing it asks you is first curve, and it's showing up here the first equation I put in, y equals 2x squared minus 8x minus 6. It's got a question mark. Is this your first curve? Yes, I hit enter. Then it puts up y equals 0. And it's asking me, is that your second curve? I hit yes. A lot of kids accidentally stop here. I don't know why it does this, but it says guess. Just ignore that and hit enter again. Don't stop till you see the word intersection. Now look at the y value. What is it? 0. That's what we want it to be because we're finding the zeros of the function. The x value is that yucky weird decimal, -0.6457513. On your homework today, I just want you to give me 3 places after the decimal. You don't even have to worry about rounding or anything. It's called truncating. You just drop everything else off. So what would you put down for your x value? -0.645. So one of my x-intercepts, one of my roots, one of my zeros is x equals -0.6. What was it? 45. That was this one. Isn't that between 0 and -1? Now, I still have to find the other one. How do I get over there? The calculator is going to keep telling me the same one that I'm next to. I need to move my little blinky cursor over to the other side. And then I got to do this whole thing again. Now, the way I do that is with the trace key. The trace and calculate key are the same key. When you hit trace, do not hit the up and down arrow, because that will jump you off of your parabola. Hit trace, and then hit the right or left key, depending on which way you need to move. I just need to get over there to the other side. I don't have to be right on it. I just have to be closer to the other root, somewhere on the other side. And then I do that whole thing again. Calculate, intersection, enter, enter, enter. So now I'm going to use the trace key, except I need the calculate function. So I'm going to go second, calculate, intersection, enter, and it asks you first curve? Yes. Second curve? Yes. Guess? No, thank you. Just keep hitting enter until you see the word intersection, and until you see that the y value is a 0. Well, this is what they do. This is how they would ask you to, on an end-of-course exam, and I have seen them do this before. There's two x-intercepts here, right? One of them we already found, negative 0.64, whatever it was, negative 0.645. What's this one? Positive 4 point, give me 3 places after the decimal. 645. Now, they might ask you on this question, give me the positive x-intercept. So which one would you tell me? 4.645. They might say, give me the negative x-intercept, which you would tell me negative 0.645. They might ask you for both. Now, how could I answer it? This is a perfectly acceptable answer. There's two different x values that give a y value of 0. Or you might see it as points, negative 0.645, comma, 0 and 4.645, comma, 0. Or you might see it in set notation, negative 0.645, comma, 4.645. What you shouldn't see, and what they wouldn't do on the end-of-course exam, is you shouldn't see these two in parentheses, because that makes them look like a point. These two numbers don't make a point together. These are two different x values that have a y value of 0. So you'll either see it as separate points, or just as x equals, without the y value of 0, or you might see it in set notation. I don't care which way you show me. All right, let's try another one, number 2. Let me go back to this one. I'm sorry, real quick, before you clear that out. Let me show you common mistakes kids make. They know they're finding zeros. They know they've got to enter the y equals. They know they're supposed to do intersection, but they forget to tell the calculator that we're trying to intersect this with y equals 0. So they put in one function rule. And they go second function, calculate, intersect. And look what my calculator is going to try to help me out here. It's going to say first curve, question mark. I hit enter. And then what does it do? It's going second curve, question mark, second curve, question mark. It's saying second curve, second curve. Hey, dummy, you didn't put in a second curve. You can't intersect with just one equation. So the biggest mistake I see here is forgetting to put in the y equals 0. If you know the y value but not the x value, this is how you have to do it. You put in y equals 0, and then you see where they intersect. All right, here's another one for you. Number 2. Y equals negative x squared minus 2x minus 2. Try that one. I see confusion. I picked this one on purpose, and you will have some like this. It says error. Why in the world would it say error? It doesn't intersect. This is why it's a good idea to always look at the picture first. Okay, so I'm going to put in that function rule. Y equals negative x squared minus 2x minus 2. And I'm going to just glance at the picture real quick. Is that ever crossing the x-axis? No, look at it. The vertex is below the x-axis, and it's a frown. It's opening down. It's never going to cross the x-axis. So it will never equal 0. It will never have a y value equal to 0. Let's say I didn't look at the picture, because sometimes I forget to, and I just put in my two functions. I put in the function rule. I put in y equals 0. and I try to get my calculator to calculate the intersection, and it asks me first curve, second curve, guess, and then it's going to tell me error. And it doesn't even have, usually when you see error, you have a quit and a go to. Do you see how there's no go to option? Because the calculator is trying to tell you, you didn't make an error. You didn't enter something incorrectly. It's just I can't find two things, the intersection of two things that don't intersect. So it's just telling me there's no sign change. It just means that they don't intersect. So what would you put for the answer for Miss Heim? No, don't put error. Don't put no sign change. Don't put 0. No roots. There are no roots. Remember, not every parabola has roots. All right, one more. I'm going to let you try, and then I'll let you do your problems for your assignment. You should be able to finish in class, I hope. Are you ready to just try your problems on your own? All right, just one more real quick. I'm sorry. One more. Y equals x squared plus 8x plus 1. There are roots on this one. Find them both. There should be 2 of them. How did you guys like using the calculator on the tablet? If you still don't have it on your tablet, please let me know so we can make sure you have to have access to a graphing calculator at home. Especially like today if you don't finish the 10 problems. Say that again. 30 minutes to install it on your... Did anybody put it on their phone? Nobody? Don't touch up and down. Okay, and somebody first period asked me, why did you make us do so much factoring when we can find the answer with the calculator? Well, I don't know if y'all remember your CBA, but a lot of it was just factoring. They don't always ask you to solve. Sometimes they just want you to factor something. So you absolutely have to know how to factor. Okay, one of the zeros I found was negative 0.127. Now, to find the other one, I got to hit trace, get over there to the other side, do it again. So negative 0.127 was one of the x-intercepts, or zeros, or roots. Get over to the other side, do it again, calculate intersection, first curve, second curve, guess. Please make sure you don't stop till you see the word intersection, and the y value should equal a 0. The other one was negative 7.872. All right. All right, you have got plenty of time, I think, to do page 444, 1 through 10, under written exercises. And please ignore the directions. My directions are to find roots, if there are any. And I'm telling you, there will be several that don't have roots. There will be some that don't have roots. But if it does have roots, you got to find them for me. If it doesn't, you would just write no roots. You don't have to show work here. This is completely calculator. So those of you who hate showing work, this is your day to shine here.